Hello, this is Charles LeBuff again, bringing you episode 26 of my YouTube channel I've named Sanibel Chronicles. I wanted to start off with today's episodes, a series of episodes featuring the Sanibel Lighthouse. But in recent days, there have been some articles in the news press, Fort Myers paper, and also various television stations have aired some footage and stories about red tide. And I thought I'd interject this episode and deal with the red tide phenomena as I know it. The red tide is, despite what some people say, it's not a new event. They've been going on since at least biblical times, and there is documentation of red tides in the Gulf of Mexico going back to the 15 and 1600s here in the Gulf of Mexico. It's when suddenly out of nowhere, millions of fish and other marine creatures float in dead on our beaches and wash into our mangroves and produce a general stench in the air. If you've never experienced one, you really don't want to see one, but you never know when they're going to occur. Before I get started, I want to bring to your attention that a couple of years ago, Betty Anholt and I produced this book, Once Upon the Island Known as Sanibel. It's a large book. It's 8 by 10, has nearly 500 pages, and it's just full of information on Sanibel and Captiva. But why I mention that book is because the last chapter in this book is called Red Tide. And in my opinion, and in the opinion of several other people, this is one of the best articles that explains the history of red tide, the causative agent that brings it to us, and what is being done to try to understand it better. So what I thought today, I'd bring you a person-to-person story about red tide as I know it. In 1956, I started my federal career with the Bureau of Commercial Fisheries. The Fish and Wildlife Service was broken into two prime bureaus, the Bureau of Commercial Fisheries and the Bureau of Sport Fisheries and Wildlife. Later on, the Bureau of Sport Fisheries and Wildlife condensed to become the wildlife refuge system of the U.S. Fish and Wildlife Service. So in 1956, I took a position at a marine laboratory operated by the Bureau of Commercial Fisheries. It was located out at the old Naples airport that was built during World War II. The lab was housed in one of those old barracks buildings. And we began a relatively long-term study on red tide, trying to determine things like its cause and how it can become so abundant, kill so many fish, just general things. But in order to get a handle on that, I have to take you back until 1946. That year, along the southwest Florida coast, there was a massive outbreak of red tide. That's where the water is actually in severe blooms, as they're called, when the organism that causes the problem procreates to such a level that the water is a rusty red color and even appears to be a different viscosity. It seems to be closer to a syrup than to water. And I've seen it just that bad, believe me. Doesn't always happen that bad, but I've seen it that way. So in 1946, a scientist collected water, and he was able to identify a new organism He gave it the scientific name of Gymnodinium brevis, and it was recognized as the cause, the organism that brought death to so many marine creatures. That same year, unbeknownst to the researcher who identified the red tide organism, Ding Darling was at his winter home on Captiva, and he noticed the massive fish kill, talked to Tommy Wood, the refuge manager, and other longtime residents, and no one could tell him what caused it. There were all kinds of legends of what caused it. One of the most common among the early peoples in this area was that after World War I, the U.S. Army dumped thousands of canisters of mustard gas and other chemical weapons into the Gulf of Mexico. And periodically, these canisters would rupture and release some of that gas or liquid, and that would cause the massive fish kills, and then, of course, the carcasses would then wash on the beach. But in 1946, the culprit was identified as a living creature. So Ding Darling couldn't find anybody that knew much about red tide, and there was no one researching it, no government agency, no university. So he took it upon himself to contact the University of Miami Marine Laboratory, came into an agreement with them where he would fund a group of marine biologists to come over here to the west coast of Florida and begin studies on the events of red tide. They didn't learn too much, but they fulfilled what he was asking for. And then the study of red tide sort of dropped again. But Ding Darling had tremendous connections in Washington, and I'm sure through his antagonistic approach to politicians, he got things to happen. So in 1956, 10 years later, the Bureau of Commercial Fisheries set up their laboratory in Naples. So this is a slide of Ding Darling taken back in those times. He was an avid fisherman and sportsman. He couldn't stand the demise of all of these fish. And we're not talking about small minnows and group fish like mullet. We're talking about enormous snook and tarpon and redfish, fish that he sought in his fishing trips with Belton. So he gave a push finally to the right person in Washington, and Commercial Fisheries set up that lab in Naples. I'm sure it's through Ding's efforts that happened. So the studies continued, and I took my position in 56, and I was assigned as a fishery technician. I was sent out to collect water samples for the microbiologists to study and check organisms, count levels of Gymnodinium that were present in the water. And incidentally, the organism, the dinoflagellate, is present in the Gulf of Mexico all the time. Unless it's in a bloom, it's not dangerous to the marine resources. It's only when they bloom, and those blooms will go from a normal population of about 1,000 of the organisms per liter of water to about 3 million. And that's when the water turns the reddish color, and its quality becomes more heavier than typical water because it's just crammed full of these organisms. So when the organisms bloom, they die. And as they die, they release a toxin that is called brevetoxin. The brevetoxin gets in the water column, and we knew from those 1946 studies that it killed the fish. There was no survival once the fish swam through a section of water body that was completely full of these dinoflagellates. So the studies continued, And in my work, I'm trying to find an image here so I can describe what I'm going to put on the screen. As I mentioned, the first image was Dean Darling and Belton Johnson in a skiff fishing somewhere near Captiva. And this next shot is when I was active with the red tide lab. We had a minor red tide in the latter part of '56. And this is me on the left with my supervisor, Alex Dragovich. Alex was a fantastically perfect. You couldn't get any better of a microbiologist than Alex Dragovich. And he was my supervisor. And that's a small snook we have between us. And I was digging through some of my images, and this next one is the research vessel that was kept anchored in Creighton Cove in downtown Naples. And it had a permanent captain and a mate cook that lived aboard the boat. And it was in constant use. I would go on it at least 2 times a week, run offshore, collect upper and water bottom samples, and then I would take a car and drive to spots along US 41 at near the mouths of rivers where I could collect water samples, both surface and bottom samples. And then, of course, as I mentioned earlier with the aircraft, the aircraft that was assigned to Sanibel and used part-time in the red tide research, I take trips in that a couple of times a week. The next slide is a slide that I happened to dig up somewhere. This is a photograph of the Punjab. The Punjab was a patrol vessel operated by the Florida's State Board of Conservation. And I mentioned in the last episode, I believe, I talked about Jack Levins. And Jack Levins was the skipper of the Punjab during my red time days. Later, his brother-in-law, who became a Marine Patrol officer, his name was Benny Whitehead, he skippered the boat, and I took several offshore trips with him collecting water in deep water in the Gulf of Mexico. And it's funny, but in 1960, when my family and I returned to Sanibel 3 days after Hurricane Donna passed over it, the Punjab was the boat that took us back to Sanibel. It was taking Sanibel citizens from Punta Rasa to Bailey's Dock on Sanibel. Well, time passed. We had a few minor red tides in the 60s. But then in 1970, we had a massive bloom of the dinoflagellate. And you would think, walking along the Sanibel beach, that everything in the Gulf of Mexico had died and washed up on the shore. And this is a couple of images of dead fish. The first one was taken at the Sanibel Lighthouse on the bay side. You can see the causeway faintly in the background. And the second image is a shot of primarily mullet that died from the impacted water and floated up in the mangroves. It was terrible. We were under Lee County government then, and they finally took action and sent dump trucks and road graders to Sanibel, and they would push up the dead fish after every tide, and a loader would put the dead animals into dump trucks, and they would take them to the county landfill. And they came to the refuge, the county did, and asked if, since they had just done work in the Bailey Tract for us, if there was somewhere they could start burying the fish rather than having to transport them all to the interior of Lee County to the dump. And Bob Barber, the second refuge manager, was the manager at the time, and he authorized them to dig a burial pit that was the eastern end was at the almost to the lighthouse on the beach, and the western end ended fairly close to the lighthouse reservation boundary, about 1,000 feet away from the lighthouse. And they would dig these long trenches with the road grader, and they would dump the fish into this pit. The pit was basically kept open until the cleanup was completed. And believe me, it was not a very, very friendly odor that we enjoyed at the lighthouse. But the red tide organism, here's a shot of the organisms through powerful microscopes. They're the large round-looking things that are primarily the most important thing in the image. And they were known as gymnodinium for several years. And after the Fish and Wildlife Service left the research portion of red tide, the lab that I was in had moved to St. Petersburg Beach, so I left that and waited to go on to the other job. And they stayed there for a couple of years, but then they finally turned the program over to the state of Florida, who still maintains a significant interest in the problem and conducts counts of organisms. And the Mote Marine Laboratory up in Sarasota is one of the major institutions that maintains a variety of studies on the red tide organism. And this next shot is the Florida Fish and Wildlife Fisheries Commission, FWC, to make it short, produces to notify folks that may be going to the barrier islands how intense the red tide blooms are when they are in existence, when they are actually actively in a bloom episode. Well, the studies kept going and the red tides continued in lesser extremes. And then in 1982, we had another red tide. They did something different. It just didn't kill marine animals, fish, crabs, some shellfish. It traveled further upstream in the Caloosahatchee and got as far as about near the railroad bridge or the Edison Bridge in Fort Myers, in that general vicinity. And the red tide organism-laden water reached that point. And at the same time, manatees feeding in the Caloosahatchee estuary were feeding on sea squirts, tunicates that had attached themselves to the food material the manatees ingest. This is a seagrass, sometimes called turtle grass, and you'll see the tunicates attached to the grass. Well, the manatees got up into those grass flats, feeding as they normally would, and the tunicates, the sea squirts, are filter feeders. They do a great job of cleaning water, and they would take in all of this dinoflagellate laden water, and the organism would be retained in their system, and the manatees would consume the grass and the tunicates, and we had a mass mortality of manatees for the first time associated, as far as I know, with red tides. By 1982, manatees had probably increased at least sixfold over the previous 20 or 30 years. Manatees were were unusual to be seen here. And today you can go to many places where you have access to the water and see manatees. And this is just an example. It's not a nice picture to look at, but it's a fact of life. These are two manatees that died because of brevetoxin. So a pretty sad thing to see. But at the same time, dead turtles, sea turtles, were washing in on the beach. And this is a image of me measuring a dead loggerhead turtle that had washed up on Sanibel Island. Now, it's very, very interesting in that during the 1971 red tide event, which ran from late June until mid-August, it was really, really bad. I mean, you could go up to the rocks to go fishing. Most of you don't know where the rocks are. Some do. I've had questions about the rocks. Maybe someone could ask me about the Sanibel rocks sometime, and we'll make that a little story. The turtles, total strandings of loggerhead turtles during those probably 2 months total time of concentrated bloom of red tide, there were only 18 loggerhead turtles that washed in dead on the red tide because of red tide ingestion. Those that I necropsied, a necropsy is a examination of a wild animal's internal makeup. It's much different than a regular autopsy conducted that is applied to the human autopsy. Necropsy is wildlife or wild creatures examination. All of those turtles that I examined, I didn't examine all 18, but their gut was crammed full of pen shells. Pen shell is a common bivalve that washes up on the beach here on the barrier islands. But they're very abundant offshore, and these loggerheads all had pen shells in their stomach contents. And the pen shell is a filter feeder. They ingested the brevetoxin, built up a high toxicity in their system, and these killed the loggerhead turtles. Now, since 1982, when we first noticed manatee and sea turtle loss, there was another major red tide in 2018. That was bad, but based on personal experiences and the experiences of people who worked with me in my sea turtle research, the 71 red tide was far worse insofar as the number and species of fishes that washed ashore. But in the 2018 red tide, there were well over 150 sea turtles that washed in on Sanibel Captiva, and I really don't have an exact handle of why that increase happened. There are several factors that could come into play. We do know that the populations of sea turtles in the Gulf of Mexico of 4 species at least has increased many, many times since 40 years ago in 1971. And perhaps the conservation efforts that have been made in Southwest Florida since 1971 produced more hatchlings produced more breeding adults, and there was probably a lessening in predation. The survivability of hatchling sea turtles is actually greater than what is often claimed as being 1 out of 1,000. And it could have been that the wind was in a different direction. The 82 red tide may have had winds that were blowing away from shore, and therefore the larger organisms like sea turtles would have washed out clear of the beaches. But that doesn't connect in reality to the numbers of fish that still floated in. You know, big fish, heavier than sea turtles, washed in on the barrier islands. So it's a great mystery. We're learning more. The state and private institutions are researching, and they now have the ability to forecast red tides because the waters, both inshore and offshore, are monitored, pardon me, couldn't get that one out, for the population of the organism. So there are two major changes that have been made since the 1950s. We can now monitor and forecast red tide blooms. That gives us, the state, the ability to close down shell fishing, oysters and clams, scallops that condense the brevetoxin are no longer permissible to collect for food. So with that, that's an overview of red tide. I hope you never come to the islands when a red tide bloom is in effect, because you'll find it's very difficult to tolerate the odor. Once the brevetoxin is released by the dying dinoflagellate, it becomes mixed up in the waves at the water's surface, and it becomes aerosoled, and the wind carries it on shore. And people that have respiratory problems often have serious effects because of the red tide toxin that's airborne. It's not a very nice situation. And there really is no way to control it. We know how to kill it. We can kill the organism in an isolated container, for example, but we can't do it in nature. It's an impossibility. So it's something we just have to live with and tolerate. Oh, the other thing that I was going to mention that we've done in red tide research, we've changed the generic name of the red tide causing dinoflagellate. It's no longer gymnodinium, it's Carenia or Carenia. I don't know how they're pronouncing it. So that's the big change in learning more about red tide. We can forecast it, we can call it by a new moniker, but we still have to tolerate the experience of a red tide every so often, every so many years. And there's a lot of blame, I forgot to mention this, there's a lot of blame on fertilizers and wastewater that's being discharged to our groundwater aquifer, both inland and on the barrier islands, that these fertilizers and other discharges are increasing the frequency of red tide blooms and are also causing the blooms. Well, you have to consider that historically, most of the red tide blooms started well north of Sanibel. And they're far enough north, they aren't impacted by the discharges of the Caloosahatchee, at least not at the onset. They may be because the currents along the coast move to the south, and those blooms come south along the peninsula and carry that toxin to our area. So that's Red Tide work and studies and information in a nutshell. Check out Once Upon the Island Known as Sanibel at a library. Buy yourself one. Buy someone else one as a gift. I'm sure if you love Sanibel Captiva, you're going to get a heck of a lot out of that book. With that, I'll leave you. And I forgot to welcome the new subscribers. We've gained quite a few since the last episode, and I appreciate that. And the comments have grown. But your question of the week is, what do you know about the Sanibel rocks? With that, I'll leave you and see you next time. Please subscribe. Thank you.